Assalamu alaikum to all viewers. Welcome to my channel. In this video, we will discuss about the replication polymerized chain reaction. We will discuss about that about the chain reaction in this video, which is polymerized. So let's start it. DNA replication and the polymerized chain reaction. Here you can see that the history of polymerized chain reaction. The polymerized chain reaction was not a discovery but rather than an invention. A special DNA polymerase is used to make many copies of a short length of DNA. Defined by primers. Karamolis, the inventor of PCR, was awarded the 1993 Nobel Prize in Chemistry. What PCR can do? PCR can be used to make many copies of any DNA that is supplied as a template. Starting with one original copy, an almost infinite number of copies can be made using PCR. Amplified fragment of DNA can be sequenced, cloned, probed, or sized using electrophoresis. The defective genes can be amplified to diagnose any number of illness. Gene from pathogens can be amplified to identify them. Amplified fragment can act as genetic fingerprints. How PCR works? PCR is an artificial way of doing DNA replication. Instead of replicating all the DNA present, only a small segment is replicated, but this small segment is replicated many times. As in replication, PCR involves melting DNA, priming, and polymerization. Initiation, forming the replication I. You can see the more detail in another PowerPoint slides also. PCR polymerized chain reaction. PCR is an vital technique for the amplification of a region of DNA which lies between two regions of known sequence. PCR amplification is achieved by using oligonucleotide primers. These are typically short, single-stranded oligonucleotide, which are complementary to the outer region of a known sequence. The oligonucleotide serves as a primer for DNA polymerase and some other things. Also, we go to the Google and see some other detail about. And you can see here it almost describing some other things. Primer is an obligation sequence which will target a specially sequence of opposite base pairing 80 JC only for of single stranded nuclei acids of single stranded nucleic acids. For example, there is a 1 by 4 chance, 4 minus 1 of finding an AGCT in any DNA sequence. There is a 1 by 16 chance, 4 by 2, 4 to 2 of finding any dinucleotide sequence. 1 by 256 chances of finding a given 4 base sequence. Here you can see the more detail about the cycles. Here you can see the primer selection. Primer is an